Now in this video, we want to introduce limits of functions, right? Great. So in our previous topic, we were talking about functions, and there was a certain video where I had to evaluate some functions. So evaluation of function goes this way. You're just given a certain function, then you are given a point. You say, what is the value of this function at this point on the x-axis? Right. So let me give you this particular example. Suppose we have a function, f of x, to be x plus 1. Then the question will be, find the value of f of x when x is equal to 2. So when x is 2, we'll be having to evaluate f at point 2, right? Great. So by doing that, you just have to make a substitution or a replacement. So in place of x, we put 2 here. So we'll also do the same thing here. That will be 2 plus 1, right? And by doing that, our result is going to be 3. That tells us that if f of x is x plus 1, that is, it adds 1 to whatever you give to it. If you give it 2, it will add 1 to 2, and the result is going to be 3. Good. That is just by evaluation of functions. But here, in limit of functions, we want to find the value that our output gets closer to as our input gets closer to a certain number. Great. So let's visualize this a little bit on the curve. So I gave you this is the same function. This is it. This is the graph. It's just a straight line, right? Great. It's an increasing function. So it's just a straight line going up like that. Now, limit of function. Let's say find the limit of this function as x approaches, let's say 2, right? So let me clean this up so that we can see something. So as x approaches 2, what is this function? So limit of function is just what is the value of the function as the input gets closer to a certain number, right? Okay, so as we get closer to 2, now notice that on a real line, this is the point 2, we can get closer to 2 either from the left or from the right, right? We can get closer to 2 either from the left or from the right. Good. So the statement is find the value, okay, no, find the limit. Statement is to find the limit of f of x as x tends to 2. So you notice this symbol, that's arrow there. We can call it as x approaches 2, right? Great. So notice that this is a point 2. X can approach 2 either from the left, right? Going to 2 from this side, or from the right. Okay, great. Now, find the limit of this function. As I said earlier, we want to find the value or the result that we get closer to as our input gets closer to 2. It's not just the value of the function as x is equal to 2, no. But what does it get to? Okay, what is the limit? What is the boundary of the function as x tends to 2? Good. Now, as we get to 2, as we get closer to 2 from the left, we should be talking about numbers that are closer to 2 from the left. For example, we should be talking about 1.8, right? Talk about 1.9, 1.99. These are numbers that are closer to 2 from the left. Then as we are talking about numbers closer to 2 from the right, we should be talking about numbers that are bigger than 2, but very close to 2. From this part, for example, we can talk about 2.01, right? We can talk about 2.1, 2.2, and so on, but just close numbers to 2. Now, if you plug in 0.8 into this function, now, this is the function f of x is x plus 1. Plug in 1.8, into this function, the result is going to give us 2.8. So maybe let me just give you a little table of what I'm trying to discuss here. So if we have 1.8, the output is going to be 2.8. If you plug in 1.9, the output is going to be 2.9, all right? Just plug in 1.8 into this. That will be 1.8 plus 1, 2.8, 2.9, all right? Just keep adding 1 to whatever you input. All right, this is 1.99. The result is going to be 2.99. You can see where that is going. It is getting, the output is getting closer to something, as the input gets closer to 2, right? That is from the left. If you also want to check from the right, maybe I'm going to extend my table a little bit. Let's plug in 2.01 and see what we get. 2.01, the output, just add 1 today, that's going to be 3.01. Then plug in 2.2, the output is going to be 3.2. Good. Now you notice, as our input gets closer to 2, which is the point we are actually considering, the output gets closer to something, right? To 3. So you look at this, as we get closer to 2 in the graph, we'll be looking at this point gets closer to 3, right? Numbers bigger than 2. So just like that. Okay, that tells us that the limit of f of x as x tends to 2, alright, is 3. That is, as we approach 2, either from the left or from the right, our result approaches 3, either from below or from above. Good. Anyway, maybe I can give you a little definition of limit, but that will be in our next video. Then the definition is just going to stress all of this, but you just have to take note that limit has to do with what value is our output getting closer to as our input values are getting closer to a certain point. Alright, great. And maybe most times to visualize things like this using a graph is always very helpful. Okay, anyway, thanks for watching and please subscribe to my channel.